Welcome back. This is the very first video on the topic of drawing line structures. I plan to only do two total and try to keep the time to a minimum. Now, why do we have to draw line structures? The answer is very simple. First, the way I did it for you last time, it takes 5 hours just because there are no softwares that would allow you to do that. And for assessment purposes, either in this class or outside of this class, anywhere you see an organic molecule, it's most likely written in aligned structures. You have to understand what the structure means, and that's the focus of this video. So I'm going to do it for all three categories. So let's start with this compound. Before I actually get into the compound drawing structures itself, let's see if you can answer these two questions. Is this compound given an alkane, alkene, or alkyne? I can see you saying it. Yes, it is a alkane. Why? Because it perfectly fits the CnH2n plus 2 formula. So if I put 7 in, I get H16 back. And the answer is, you're right, it's 0. If it's an alkane, it is a saturated hydrocarbon. Now, there's two key words I want you to take away from this particular videos. One of them is something I may have briefly mentioned as I was walking around talking to many of you, is longest chain. What is a longest chain? A chain that contains max number of carbons. Okay. The other word vocabulary I want you to take away from this is substituent or substituents. Okay, we're going to just talk about these two really quick. Now, keep one thing in mind. With organic chemistry, the options are just as far as the sky. I cannot draw every possible combination, discuss every possible case. Some things we have to understand, and as we go along, you might run into a situation where it could either be an exception or you think is a possibility. I'd be able to answer that then and there. So as I'm trying to explain this, I'm not going to draw every single combination that is possible for C7H16, okay? But I do want to drive the point across the two key words I have written, because if you understand that, you understand the concept. All right. So without further delay, let's draw the most obvious structure that I bet every one of you probably wrote on your notebook at this point, and that's this. Let's make sure we have the right number of carbons. Yes, we have 7 carbons. So for the purpose of drawing a line structure, I'm going to put dots on top of the carbons. Why? It'll make sense. So we have 7 dots because we have 7 carbons. Now, it doesn't matter whether you start from the base and work your way up and down, or you start from the top and work your way down and up. Doesn't matter. What do I mean by up and down? I'll show you in just a second. So every dot is a carbon. So 1, I'm going up, 2nd, 3rd, 4, 5, 6, and 7. Or you could start from the top, 1, 2, 3, 4, 5, 6, and 7. If you start from the top, you end at top. You start from bottom, you end at bottom. Again, that might be depending on whether you have odd number of carbons or even number of carbons. So what does this mean? This is this. Well, every terminal carbon has 3 hydrogens, like you see. This means if you leave it this way, what it really means is this has 3 hydrogens. Every bend from now on, every bend, unless something coming off that bend, just a pure bend like this means it's 2 hydrogens, or it's a CH2 group. So a bend itself, like this bend right here, itself is a CH2. Again, this bend is CH2. Doesn't matter whether the bend is up or down. A bend is a bend, and a bend is a CH2, and a CH2 has 2 hydrogens. Does that make sense? Okay. So you do not have to show the hydrogen, but in some cases I would show, because when we learn stereochemistry, I will show them up. But without actually showing the hydrogen, the line itself means that. Now this is one of the isomers. This is one of the structures possible. What if we draw this? Let's chop one carbon from the longest chain and instead just move it over here. Now the longest chain possible is the 6 carbons, right? So that is your longest chain. So let's put 6 dots. You may want to start doing this initially before you get comfortable. You will get comfortable, I promise. So again, I'm going to start from the base. That's the way my mind works. So 1, 2, 3, 4, 5, and 6. Stop. Because your longest chain is not 7, it's only 6. So 6 dots. And for it, while this is not important right now, it is important when it comes to naming. Okay. On this side, this is where this is a substituent. Whatever is hanging off of a long chain is called a substituent. So I'm going to write the word substituent because we only have one substituent of the long chain. Okay. So 1, 2, 3, 1, 2, 3, or 1, 2, 3, 4. From this side is the 4th carbon. From this side is the 3rd carbon. But for naming purposes, let me just give you a lead. This is the carbon containing the substituent. On to the right side of this carbon, there's 2 carbons. On the right of this, there's 3 carbons, right? There's 2 carbons, 3 carbons. Typically, you should start numbering from the side that has the least number of carbons. So here on this side of the substituent, this is the substituent. On this side, we have 2. On this side, we have 3. So we start numbering from here. So it's 1, 2, 3, 4, 5, 6, and not 1, 2, 3, 4. The substituent is in the 3rd carbon, not 4th. You don't start numbering from this side. This is the correct numbering. I have it here. This is just a lead for what is to come in the next future video. So do I put it down or above? It absolutely makes 0 difference. So if you want to put it down, put it down. Okay. Now, do I just draw a line or do I draw something else? Well, that's the question. There's only 1 carbon. Every carbon is a dot. So if you want, put a dot and connect the dot. Okay. Connect the dot. Okay. That's it. Okay. That's it. You got your 7 carbons. And this means this has 3 hydrogens. Okay. That's really what it means. Okay. What if I do this instead? Okay, CH3, CH, CH3, CH, CH3, CH2. Let's keep track of 4, 6, 7. So 1 more. So again, the longest chain is 5 because you can try any combination. 5 will be the largest possible. I think the next big would be 4, but we want the longest chain. So we start from the base, 1, 2, 3, 4, and 5. Stop. 5 carbons is all we can have on the longest chain. And we have 2 substituents. This is one and this is the other. Where do we start numbering? Well, there's 2 substituents. Clearly, this is 1. This is 1. You look on either side of the substituents. Either pick, you take both at a time. On this side, we have 1 carbon. On this side, we have 2 carbons. So things will get more complicated, I promise. So I'm trying to make it very simple on you. So traditionally, you would start numbering from this side because that side has the least number of carbons. Again, this is not something you need for this video. You do need to get used to that idea. So do I put it top or bottom? Well, there's only 1 carbon sticking from each that contains the 3 hydrogens, right? So put it this way. Because essentially, you're connecting dots to dots, and that's it. Is that simple, easy, difficult? Okay. So this is how you do line structures. Now I'm going to wrap this video here for alkanes, and in the next video I'll try to cover both alkenes and alkynes really quick. All right, so stay tuned.